This is the quadratic formula. You'll need to know this, probably memorize it. Sometimes I do like to split it up. Stuff like this happens with students. Sometimes you have something like 4 plus 2x all over 2. And students sometimes will make this kind of mistake. They'll cancel here and leave this guy unaffected. Really, that's not fair. You're butchering in a sense. Because really there's two different fractions there. The way you could cancel is if you take out a 2, factor out a 2, 2 times 2 plus x. Now the 2's would cancel and you're left with 2 plus x. So you're allowed to do that if you cancel both terms up there, not just one of them. So because that is so common with quadratic formula, sometimes I'll just go ahead and start off. There's another advantage too, but I'll consider this like two different equations. Like that's an equation and that's, two different fractions there. So I can write this as x equals negative b, or opposite of b, over 2a, plus or minus, all over 2a here, square root of b squared minus 4ac. That's a 4 there. And so let's try this. So I'm going to try it my way, which is to split it up first and see how that works. So again, so the coefficients here, the coefficient there is 1. So the coefficient a would be 1. Ax squared is standard form, plus bx. So b would be negative 2 and c would be negative 4. So make sure those negatives go with your a, b, and c there. So following the form here, we get x equals opposite of b, which is opposite of negative 2, which is 2, over 2 times a, which is 1. Plus or minus square root of. Now you got to be careful on this step here, so this b squared, because that's always going to be a positive value. So even if b is negative, like here, negative 2, when you square it, it's going to be positive. If you write that out, you'll want to write it this way, in parentheses, negative 2 squared. Now what I prefer to do is I just go ahead and I square it and make it positive. So I'll put a positive 4. That'll always be a positive number right there. Minus 4 times a, which is 1, times c, which is negative 4. And this part up here, this part can get a little confusing. So sometimes, and it takes usually a few steps to kind of simplify that. So sometimes what I'll do is I'll kind of work outside of here. So I'll just kind of off to the side kind of simplify this. So I'll say 4 minus, and then I'll kind of multiply all three of these guys together. So 4 minus 4 times 1 times negative 4, but that's negative 16. If I write it that way, I can easily see there's a double negative there. I'm subtracting a negative number, so boom, boom, I'm adding a positive number. And you get positive 20. So that 20 goes back into under the square root there. So we're ready to come back to our equation, simplify it a little bit. So here would be 2 over 2, which is 1, plus or minus. This is square root of 20 over 2. And that can be simplified just a little bit more here. So we could say that x equals 1 plus or minus. We know that square root of 20 is really 2 root 5, sorry. 4 times 5 is 20. And then you can cancel out the 2's. So you're just left with x equals 1 plus or minus the square root of 5. And that's our answer. That's as simple as it gets. And that's an exact answer. So that's actually two answers. 1 plus square root of 5 and 1 minus square root of 5. That's why sometimes our answers comes out separate anyway. That's why, again, when I started out, I said, well, I like to separate it out. Oftentimes our answers are separated, so it kind of works out nicely in some cases. Let's try this one. This is kind of interesting. So if you try this one, again, we're going to go x equals the opposite of b, so negative 12, over 2 times a, which is 4, plus or minus. And this is over 2 times 4 also. Square root of b squared, again, I like to write just b squared, which is 144, minus 4 times 4 times 9. Then off to the side, I'm going to kind of figure this guy out. So this is 144 minus 4 times 4 is 16. 16 times 9, I think, is 144. 144 minus 144 is 0. So 0 goes back in there. Well, this is just kind of interesting. So we get x equals negative 12 over 8, or negative 3 halves, plus or minus. And this is over 8. This will be 0 over 8, or maybe I should say square root of 0 over 8, which is the same thing as 0 over 8, which is really the same thing as 0 right there. Well, if I add and subtract 0 to any number, that just goes away, right? So I really have my answer as x equals negative 3 halves. Now notice, in this case, I only got one solution. It's kind of unusual. Anytime this value is 0, I'm going to get one solution because you're adding and subtracting 0. It kind of makes sense in the context of this. Let's take a second and just factor this guy. If I were to factor this, this would be, kind of recognize it, 2x and 2x. Square root of 9 is 3 and 3, and it's plus and plus. I think this works out. Yes. In fact, if I were to write this, a mathematician might write this like this: 2x plus 3 squared equals 0. Can you see why there's only one solution? When you set the factor equal to 0, you get one solution because it's the same factor twice. So that's an interesting case. The graph of this would only have one solution. It's because the parabola only touches at one spot, right? It touches just there at x equals negative 3 halves. It only has one solution. It only crosses the x-axis once. So now we get to something called the discriminant. This is kind of a shortcut we use. You can write that down. But the big thing here is underneath the radical, all that is the discriminant. In fact, the formula is b squared minus 4ac. Does not include the radical. So do not include the radical as the discriminant. It's just what's underneath the radical. Right? B squared minus 4ac. Oh, it doesn't include the radical. Made a big point about that. So if you have, what this does, discriminant tells us about the type of solutions, how many solutions and what type of solutions you might have. So if we just plug in the discriminant, let's see what happens here. So we get, we're going to plug in b squared minus 4ac. So the discriminant equals b squared. In this case, that would be negative 6 squared, which is 36, minus 4 times a, which is 1, times c, which is 9. Well, 36 minus 36 is 0. Didn't we just have a discriminant of 0 in the last problem? How many solutions did we have? You're adding and subtracting 0, right? So the first case is if the discriminant incidentally, I think Word does not know discriminant as a word, but it is. I'm talking about Microsoft Word. It always underlines it, and it actually is a word. Unless I'm misspelling it, but I think I'm right. If the discriminant is, maybe I should say it this way. Let's move it over. If the discriminant is equal to 0, then there is one real solution to the quadratic. So that's the first case of discriminant. If discriminant is equal to 0, you're adding, subtracting 0 in the context of the quadratic formula, so that's going to be the case. Let's try this one. So let's set this equal to 0 first of all, so we have an equation. So let's figure out the discriminant. Again, it's pretty quick. Discriminant equals b squared, which would be 9 minus 4 times a times c. 9 minus 12 is negative 3. Well, that's interesting. So in the context of the quadratic formula, right, we're going to have opposite of b over 2a plus or minus all over 2a. If we have inside of here, if this goes right there, we have square root of a negative. Well, what would happen if you take the square root of a negative, right? Well, you won't get a real number. Square root of a negative, we know this much. It's imaginary, right? We haven't learned exactly how to do that, but we know that guy's imaginary. And so at this point, we're going to say, okay, we're adding and subtracting an imaginary number, so neither of those roots are real. So I'm going to say there are 0 real solutions. There would be some imaginary solutions, but right now, I don't care about those. I'm just going to say 0 real solutions because we haven't learned about how to find those exact imaginary roots. And one last example here. So in this case, and this is a pretty normal case actually, let's find the discriminant. Discriminant equals b squared is 4 minus 4 times a times c, which is -3. That's 4 minus 4 times 1 times -3 is -12. I've got a boom boom. Subtracting a negative. 4 plus 12 is 16. So in the context of the quadratic formula, and again, I don't care what these numbers are for this particular problem. What I care about is how many solutions will I have. If I'm taking the square root of 16 and add it over some number, and you're dividing it, I'm going to get 2 different answers. And they're both real, because if I plug in numbers for a, b, and c, this will be a real number. So I will have 2 real solutions. If you want to get picky here, we could actually go a little further. This is such a nice number, it's a perfect square. Square root of 16 is 4. That if it's a perfect square, you'll actually have 2 rational solutions. If this is not a perfect square, you'll have 2 irrational solutions. But again, this is if the discriminant is greater than 0, then there are 2 solutions. Let me go back up and make sure we get this. If the discriminant is less than 0, then there are 0 real solutions. So those are the 3 cases that we have for the discriminant. And so if we just want to find out how many solutions, why solve it out all the way? We can just figure out the discriminant and kind of go from there. That's the lesson.